remember that the variance is the standard deviation squared. Why am I saying that? Because this particular problem, if you tried it on your own and you didn't get the answer in the back of the book, chances are that's what you lost track of. This particular problem is designed to see if you're watching for that. Now let's look. Samples of 5 cans are to be selected periodically from a canning process that has a variance of 0.2 ounces when in control. What is the standard deviation of the sampling distribution be? Oh, wait. Okay, now, unrelated to this business about, well, what is this very short problem designed to make you watch carefully? It's asking about the standard deviation in the sampling distribution. Oh, right. Something else to remember. A process can vary, naturally. This one does. We're told to the tune of a variance of 0.2 ounces. The degree to which a process varies, if you're watching its output, like thousands of cans an hour, is not the same thing as the degree to which samples from that process vary. Oh, this particular problem is asking us to find the standard deviation in the samples, now very often symbolized sigma, standard deviation, right? X bar for the sample means. That is the original standard deviation of the process divided by the square root of n. It's like a little adjustment. There's the standard deviation in the process naturally, and then there's the natural variation in samples from the process. That natural variation in terms of a standard deviation is the original one. It's just trimmed a little bit by dividing it by the square root of the sample size. That's all. You say, all right, well, yeah, that's really simple arithmetic because samples of 5 cans, there you go, n equals 5. I can see what goes in the denominator here, square root of 5, and then I need the information about variation in the process naturally, and it says, right, the variance of 0.2, so I put the 0.2. Don't write 0.2, okay? Don't write 0.2 because that's the natural variance in the process. And to complete this formula, you need the natural standard deviation in the process. You've got sigma squared. That's what you were told. You need sigma. It's really simple. That's just the square root of that number that you were given. It's this number in this particular problem, not that one, that belongs right here. The square root of 0.2. Put that number there, conduct these particular calculations, and I get that the standard deviation in the sampling distribution is 0.2. If you say, okay, the square root of 0.2 divided by the square root of 0.5, you get 0.2 back. And you might think that's the answer. You go, well, wait a minute. We're back where we started. We're back where we started because I was told that it was 0.2 to start. Oh, be careful. You were told that the variance in the natural the variance in the natural variation in the process, its variance was 0.2. You were asked to calculate the standard deviation of the samples variation. You used the formula. It's a kind of a coincidence with this particular problem that also came out to 0.2. It was just the particular numbers that we were working with. You actually have in this 0.2 up here in the problem and in this 0.2 down here in the answer is talking about two very different entities. One's a variance of the process overall. The other one's the standard deviation in a different distribution in the sampling distribution.